Welcome to another episode of GraphQL Radio. My name is Andreas Heiberg and I am the engineering manager here at Stellate. Today we're continuing our Building in Public series. For this episode, I'm joined by 3 of my colleagues to discuss how we deployed the biggest change to our system since the company was founded. Internally, we have for months been calling it One Edge Provider, or OEP for short. This is where I would normally say that this has been a lot of fun to get this out to customers. But to be honest, the story of One Edge Provider wasn't all smooth sailing. We learned a lot and we're happy with the outcome, but we had to endure a lot of difficult moments. Let's start with a round of introductions. Perhaps Dominik, as the project lead, you could kick us off.
Yeah, all right. Hey, I'm Dominik Petrick. I am a backend engineer for the last, let's say, 7 to 8 years. I've been at Stellate for roughly 11 months, or almost 12 months. My 1-year anniversary is coming up, I think, on the 22nd. I have been specialized in backend engineering since my Microsoft days when Wunderlist got bought and have been in that space since then. I've enjoyed building backends that actually deliver a ton of traffic to customers that sit in the critical path. And yeah, that's pretty much it.
Awesome. Stephan, how about you?
Hi, I'm Stephan. I'm a backend engineer at Stellate. I've basically been doing backend for my whole career, so for the last 8 years, I think. And I barely ever touched the front end. I'm working for Stellate for a bit over a year by now. I've been mostly doing TypeScript beforehand, and with the upcoming project that we're about to talk about, I started my transition towards Rust, which was an exciting journey. And yeah, I guess that's it.
And how about you, Thomas?
Hi, I'm Thomas, not a backend engineer. I'm also a front-end engineer. I'm full stack, with in the past maybe a bit more front-end focus even. I've been here at Stellate for 1 year and 6-7 months or something. Similar to Stephan, actually, I've been mainly focused on doing JavaScript and TypeScript in the past. And for me also the One Edge Provider project was the first real chance for me to get my hands dirty with Rust, which was an amazing journey.
Yeah, sounds good. Let's kick this off then, guys. Yeah, I was thinking we could start by talking way back in the day, giving some context on how Stellate came to be back when it was called GraphCDN. You know, there's a deep history, and I guess maybe Thomas would be best to talk about this, around why the stuff that we had was there and why we felt it was necessary to change it, right? So, Thomas, can you tell us a little bit about L1, L2, L3, Rust, TypeScript, all the different questions that come in here?
GraphCDN back in the day, how it came to be was essentially, even before, way before I joined, it was Tim and Max kind of sitting in an apartment and hacking stuff together and making shit work. That was how it came to be. And that is also how the first kind of major version of our CDN layer came into existence. And it was built on not just one cloud provider, but actually 2, which were Fastly and Cloudflare. And you might wonder why 2. Why couldn't they just do just Fastly or just Cloudflare or just something else? And there were pretty good reasons for it, to be fair. Both platforms at the time kind of had limitations that didn't allow Max and Tim to fully build everything on one provider. For example, Fastly offered the super fast purging that was kind of necessary in order to avoid reading stale data after cache purges. But it didn't really support a JavaScript runtime at the time. I believe it's still in beta today. And whereas much of the GraphQL ecosystem is written in JavaScript, and both Tim and Max were rather JavaScript engineers than Rust engineers. So that's where Cloudflare came in. Also, what Cloudflare offered, what Fastly at the time didn't, was a good storage solution. But Cloudflare has KB, which Fastly at the time didn't really have something that could compete with that. And that was basically, they took both providers and meshed them together into a set of what we then call different layers. We had the first layer, which was Fastly, and actually also a second layer that was again Fastly. The purpose of those layers was basically rewriting post to get requests. So that's basically the magic sauce behind how we cache GraphQL. We rewrite post to get requests. At least that's what we're doing now. And then there was a third layer, which was living in Cloudflare, which was then doing all the actual caching logic and connecting that with the config that the user stored via Stellate, and then actually sent the request to the origin server. So that's a very summarized origin story of how our initial version of that came to be.
I like that. That's a very good summary. Talking about, we had this great system using 3 different layers, and we started to ponder maybe changing it. When did those conversations start? I'm not even sure who's best here. Thomas, you obviously have a lot of background, but maybe Stephan also knows. When did we start talking about removing all these layers?
When I started on my first day, I think I had a get to know Stellate call with Tim, and he was like, yeah, this is like a Frankenstein architecture. Like, this won't stick around forever. I think it was always clear that this is not the best solution. And there were always, like, also with this way of doing 3 different layers, there were limitations which Max and Tim were very much aware of. So I think it was clear from the very beginning that this wasn't something that would last, I don't know, the next 5 to 10 years. At some point, we needed to go back and invest into a more scalable and like unified architecture. I can't actually recall when we actually started to think about investing time into that. I believe it was around actually the time when Stephan joined, where it got more and more concrete, and we actually spent more time also playing around with Rust more. The Fastly layers were always written in Rust. Actually, in that sense, Dom has been around longer, as Dom has been doing some freelance work, if I recall, on that Rust layer even before I joined. So we started playing around more with Rust and seeing what is possible, what things are missing currently, what would we need to build in order to move to Fastly. We also thought about what would we need in order to move to Cloudflare. But it was, I don't know how structured it was. It was kind of something that ramped up over time. I can't recall when we actually kicked it off as a project.
Yeah, I do remember that it was floating around as an idea, I think without the name One Edge Provider when I joined, which was in June, I think. Basically, when we renamed, I think the rename was done in the first week when I joined. And I remember that we were around in Austin for the conference, the GraphQL Foundation, that had to be delayed because of the whole COVID situation. And then we were around there. And while we were all together in there, we were also discussing how to move forward, what kind of people we need to hire, and where to look out for. And during that discussion, we definitely had an idea that we need more like Rust and Rust infrastructure-ish engineers joining us so that we could go into that direction of thinking about moving it together. Interestingly, a decision that we also later revised to actually compare where to move to, which I think is actually quite an interesting story to it, that we initially were like, okay, so there's definitely the need, we need to move like to Rust in order for us to consolidate onto a single edge provider. And then later on, we actually did our due diligence of like figuring out whether we actually need to do that, whether we could also move everything to TypeScript, keep the mix around, whatever. And that was only done, I think Dom even pushed for that. I mean,
Yeah, that was
can you
this
jump
year.
in here?
That was the Barcelona offsite this year.
Yeah. And in the meantime, we basically were just like working towards it. I know that Thomas was like migrating some of our code base already over. So we had that basically laying around in 2 languages, the same functionality, without even moving everything over. And then at some point we said like, okay, this needs to become a real project. This is nothing we can just like do on the side while we were yachting out what our company needs to do in terms of like features and product.
You mentioned the offsite in Barcelona, and I guess that's where we in earnest started calling this One Edge Provider and starting actually pushing for it. So I guess, can you take us back to that time? We were having very heated debates about whether we should use Rust and TypeScript, whether we should be on Cloudflare or Fastly. What kind of was the deciding factor in the end?
There's a common theme when talking about Rust, which is usually, well, it's very performant and it gives you automatic, I don't know, like latency improvements and stuff like that, right? So I think the original intent back in the day, to add a little bit context to that, was to move everything to Fastly because they started building the features that we needed. Like back in the day, it was called object stores, and then they renamed it to KVs recently. So that the feature set was there and that Rust would just be better. There was like an inherent thing about Rust that it would be better than TypeScript for the specific job, right? And then when examining these assumptions, I challenged these and said, well, but it's not really Rust. Like, yes, it is written in Rust, but it is web assembly in the end, right? So there's a huge difference between writing pure Rust binaries and how they behave and just transpiling it to WebAssembly. That started a cascade of, well, let's look into Cloudflare versus Fastly in earnest, right? Like, let's look into the specifics. Let's see if the purge times are still slow on Cloudflare, for example, right? What are plans that Cloudflare has going forward, maybe that fits better into our roadmap? What about durable objects? We wanted to build rate limiting and similar stuff at the time, right? And we thought about, well, durable objects sounds like a great idea to use for rate limiting. So they have a lot of stuff, and Fastly has arguably the faster tech in terms of latency. And so we started comparing back and forth. And it ultimately broke down to, well, Fastly is Rust, more or less. They do have JavaScript, as Thomas mentioned, but Rust is really their first and foremost SDK that they support, because most of the Fastly infrastructure is written in Rust, and they're mostly Rust people as well. And Cloudflare is definitely JavaScript/TypeScript, and there could be a path forward for us to migrate everything to TypeScript instead, right? So it broke down to, well, this is a pretty big decision for the company to make, right? Because it's not saying that we will do only Rust or only TypeScript in the future, right? But it is the core product that we would migrate to one or the other, which has impact on the business. So the impact or the decision in the end was made based on a bunch of factors, I would say. But in general, the engineering team agreed that Rust is the better tech going forward. In terms of maintaining complex systems, there is if you have a static compiler, static type system, it gives you a lot in terms of confidence, like changing a little bit of code and seeing the impact that it has, right, on your code base is something that Rust does very well if you go over the hump. Then the tech that Fastly offers, just the pure latencies of starting up the WebAssembly binary, are so much better. I think it's like 10x or something compared to Cloudflare. That was also a huge factor. And then there were a bunch of minor factors that I don't need to go into detail here. That's like the rough outline of, well, in the end we said we go with Fastly here because they also want a partnership and are pretty good at supporting us at the moment.
Yeah, this was basically my first week at Stellate, making this big decision. And obviously I couldn't provide any input, but it was very fascinating to see this discussion in my first week. And so that's awesome. So we decided that we were going to go with Fastly and we were going to go with Rust. What happened then? How do we actually go about doing this very complicated project?
Yeah, so it was already said that we had a bunch of Rust code already lying around, which was a lot of the core logic, like how to compute cache keys, basically, for the requests. And that, of course, was 8 months or not, but a lot of time has passed in between, right? So you had these chunks. Then you needed to port the core routing logic, let's say, like how the requests and how the errors flow through the system. And that was like a mapping between the callback-based way that JavaScript tends to do things, or at least our code base, and the way that Rust doesn't like to do that in many ways. And that was like the first step, getting like the skeleton of this project, of this code base right, and doing like a top-down proof of concept. Something goes through the system and it looks correct kind of way. That was a lot of going back and forth, obviously, between the code bases and making sure that I understand what JavaScript is doing in many instances, because I'm not a TypeScript engineer. I've never been a TypeScript engineer, which is an interesting position to be in. If you look, I'm a professional Rust engineer. So I looked a lot at TypeScript in depth for the first time and learned a lot about how TypeScript handles certain things and how unexpected things can happen in between, which is very different from Rust, where things are usually explicit. Not a lot of unexpected things happen if you're deep enough in Rust. So yeah, that was the very first step, and then pulling in more people as time passes, and the skeleton stands for the project was a challenge, definitely. But this is where we started out.
Yeah, I think what is worth mentioning here is we had some ported code laying around already. And obviously our main product evolved in the meantime. We found bugs, we added features, whatever. So some of those utilities that we ported were actually touched on the TypeScript code, which is in hindsight not the best idea, because now we had like implementations that weren't kept along 100%. So what Dom actually did while going through it was annotating a code in our code base, was like, hey, this portion here is actually ported, checking that back, making sure best he could to figure out that the code is actually in line, and then annotating on the function declarations like, hey, this one is ported. So you knew if you would now touch that code, you want to make sure that you also jump into the Rust code and do the same change there or adjustment there so that you keep it in sync. And I think that helped us eventually to make sure that we have A, everything ported, and B, that we can backport some of those changes, not really backporting, but like cross-porting. And that was used in a couple of occasions where we found like, okay, so we just built this. Do we actually need to backport this as well? And then most likely the answer was yes. And then we did it in there as well. So yeah, learning here, make sure to do that from the very beginning. So usually you don't want to have that code laying side by side for so long.
So if you start building it out, right, it's like you don't really have anything, and you just start comparing code, writing a few lines, and of course you have to think about, well, how do I get to anything at a certain point, right? Like, what do I actually roll out? Because what we're doing is we're sitting at the edge, we're sitting in the critical path of the customer, and there you have to think about, well, how do we actually test this or even roll it out in the end? There was a huge concern at the beginning of the project, and it came back to haunt us a few times in the process of actually implementing and rolling out this project. That's a whole other topic, of course. So if you wanted to say something else, we can first go with that.
No, let's go for it. How do we think about rollout initially, and where do we end up?
Yeah. So if I remember correctly, we went through a few options. So we basically, or the nice thing about edge computing is, well, you have one invocation, you have one request, and then it flows through the system, more or less. So now we have our, like, users point their traffic to us, their request arrives, we do a bunch of things, we do these 3 layers of computing, and then we return a response. Now we thought, well, we have a bunch of end-to-end testing, of course, that we run our system through, right? So we could build a system in parallel that simply mirrors the old JavaScript code path, and we run our end-to-end tests through that. And then we can maybe roll out a percentage of traffic over to the new system and see how it performs. That has, of course, a bunch of holes. And what we said right in the very beginning, very naive, well, all of this is very complicated to make work, like traffic splitting or traffic validation, where you replay traffic through a system. And it doesn't look that complicated, right? Like we understand the caching, we understand what went into the JavaScript implementation, and we have a lot of code already, right? So we thought, well, how about we build out, let's say, the easiest code paths first. That is like the pass-through handler, or let's say the playground handler. And then we roll that out, and like every traffic that goes through these code paths can just go through the new code path here, because they're fairly risk-free, with big air quotes right now. And so we accepted a certain risk when rolling out that production traffic can break in a very brief time window. And so we tried that. We tried rolling out, for example, the pass-through handler, and it became clear very fast that end-to-end tests alone would not save us here, because there's a lot of tiny differences that are extremely hard to spot and that are extremely hard to test for. Let's say minimal, like language differences between Rust and TypeScript, where a simple Boolean check on a string is of course different in TypeScript than it is in Rust, because in Rust you have to actually ask for if the string is empty, and in JavaScript it will just be empty string will just be true, right? So there's a lot of like tiny differences that bit us along the way, and what happened is that we ran into downtimes that we really didn't anticipate, and that really shattered our confidence in the rollout itself that we wanted to do. So in the end we went back to the drawing board and said, well, this is clearly not working, but only after we had a bunch of more lessons to be learned in more handlers that we wanted to roll out, right? So we can dive a little bit into that if you want.
Yeah, let's go for it. I guess the main lesson there is we do billions and billions of requests every month, right? And so no amount of end-to-end testing will cover all the corner cases of the entire internet going through your system. You know, weird things happen that we could not possibly anticipate, right? So on paper, it seemed like a great plan. Like, let's test a lot of this stuff. Let's roll it out very carefully in small increments. But it just didn't work for us, right? We hit our face a few times on that one. So how do we get around it? What was the next step?
So the next step was, actually maybe Stephan, you want to talk to this?
Sure.
If you like.
I think the next step was accepting that the whole internet is just like piling up mistake on mistake and rolling with it. That's kind of like how this whole system works, right? The base foundation is so robust that you could make a lot of mistakes over the years, and we are still with a functioning internet. So we have to accept the fact that the tiniest change can cause havoc. And I think I came back from vacation when that happened and was basically asked by Dominik, hey, so we now decided we actually do want a traffic replay system. You want to take this part? I was like, hell yeah. I built a traffic replay system in my past job where we had like an authentication system, an internal one that needed to be rewritten and ported to have like a different way on how it functioned in the background. But like the complete thing should obviously work the same. Like users could have their own roles and permissions defined on how things work with our own constraint solver library. Everything needed to still work. And what we did was we just replayed the traffic outside of the hot path against the new system and expected the exact same decision to be made for the roles and permissions evaluation. The cool part there was we could basically just execute more requests in the background without us caring because it was our own systems. For the traffic replay system here at Stellate, we had the problem, in air quotes, that like we can't just reach out twice to our origin, because that basically means if the user origin receives twice the traffic and it might receive twice the mutations. Yeah, they most likely are not idempotent. So like let's say an add to cart mutation or so, and boom, like now you have 2 times your shoes in your shopping cart. You would most likely not want that. So we figured out a way on how we can replay this traffic through the old and the new code paths by basically briefly storing it in the background. We made sure we had like automatic like purging of that data store and that we don't really look at that. Then tried to calculate the diffing or the diffs between the old and the new code paths, so we could make sure that we can sample traffic, see what are the differences, and then go into like our feedback loop of, okay, we look at a problem, figure it out, roll it out, sample again, see what else comes up. And by that, we found a huge variety of like different issues that can like circle back into what I said initially. The internet is a weird place. Everybody does things slightly different. And being able to catch those before rolling out greatly increased our confidence again.
I guess we can kind of go into some of the differences that we saw. You mentioned, Stephan, the internet is a weird place. You kind of did a presentation internally where you showed some of the funny moments of all the differences. So maybe some come to mind for you that the audience might enjoy.
I think my personal most fun moment was our number diffing. For a bit of context, decimals and floating point numbers in most programming languages are handled a bit weirdly, not at all that aligned between different systems. So you usually have some kind of like a safe range to operate within. It's like JSON, for example, doesn't require you to have a specific maximum size of a number, but it's usually accepted to not go over 2 to the power of 53, because that is where the JavaScript spec basically ends having precise integer numbers. And I think all the IE 754 or so, basically like the go-to floating point definition spec, basically goes to that range. So if you take numbers above that, you basically fail. Also, how do you represent actually a floating point number compared to an integer, like a non-comma places number or a decimal places number? And JavaScript, for example, says, well, we only have a number type. So if you have like a 0.0, that's basically as if you wouldn't have any decimal place, right? So you can just like cut that off. We don't care. Most other systems have, or languages have, a distinction between a floating point number and a non-floating point number, and those are literally 2 different types. So a floating point number will always have a decimal place, even if it's just 0.0. So we had users whose origin was sending us, let's say, 42.0, and we got that into one of our layers, which was JavaScript, which parsed it. Then later on during the serialization was like, oh, it's like 42.0. We can just like serialize that as 42. So what we did for our users was basically altering their response, which is not really ideal if you're just like a pass-through proxy. But nobody ever like complained. It was just like accepted and apparently it didn't cause any problems. But now the question was, now that we're dealing with a type system that knows about the difference of an integer and a non-integer, how do we deal with that we would now add a 0.0? So first of all, that showed up as a diff in our system. Here's the fun part. Our system, which displayed the diffs to us, apparently uses some part of JavaScript in the background, because the difference between a 42 and a 42.0 was basically displayed as old value 42, new value 42, you have a difference, which was very confusing initially until we found out it's about a decimal place that got stripped away. What would happen? Now we can include the 0.0, maybe somebody breaks because they expected to not get a float but an int there, wherever they would. Like the internet is a weird place. So just thinking about how a number is treated between two different systems and the impact it might have on our users was a very interesting and also somewhat funny situation to have. And I really enjoyed that. It showed that we really did our due diligence this time by making sure nothing will fail. And spoiler, you will receive the 0.0 by now, if I'm not mistaken.
No, sorry. We're stripping those right now.
Okay, so we actually decided to strip those. Nice. Yeah, it's a mess. It's a mess. I hope at some point we will be able to solve that back correctly.
Yeah, this is basically why we decided to strip the .0 is because we really don't want to, or we want to be as transparent as possible in the migration process. And we aimed to be basically a one-click migration, or even not giving the user a chance to click the button themselves, but just like swapping it over gradient as a gradient in the background, and the user would never notice, right? That was the initial goal. But the more we dove into the system, we also found bugs and issues on our old system that were just never uncovered in a certain way. And the .0 fractional strip may count as a bug, may not count as a bug, depending on the angle, but there was also stuff like cache surrogate keys not being computed correctly, which would lead to your cache being basically purged for an entire type instead of just a specific entity, and bugs like these, right? And that was leading us to deviate from the original path and say, well, let's give the user a choice. Let's communicate openly while we're building a new system, and we have very minor changes for the users mostly, but we want to be open and transparent and communicate, hey, these are the changes. Maybe your test assertions will fail. Please don't panic. If you use a snapshot test, for example, and suddenly Stellate gives you something different, would be a mild case of something breaking with the new system, right? So we planned out to really make like a transparent, open transition, write documents for the exact changes that you can happen, have a rollout period of a certain time where you can toggle back and forth between new system, like have a nice UI for that. Yeah, so this is how we got to the final shape of the rollout that is currently happening.
Yeah, we had always had this intention of making it transparent, right? And then right at the finish line, we needed to make it a user option, give them the control of moving over. And I think the initial cause for that was one of those bugs that we found in the original product, where we would leak type names, right?
Yeah.
And I guess there's like some context there around, the way that our CDN works is that you give us a GraphQL request, and we have to build a lot of cache keys based on that. But in order to know what cache keys to build, we want to know the type of the kind of the response, the types of the objects in the response, right? And so we add a lot of these __ type name definitions into the query so that we can then get this information. But we found cases where if customers had added their own type names in the request, we would fail to remove all the type names that we added, right? And so we thought, well, that's pretty simple. We're going to fix that in such an easy way. and then when we released it, everything blew up. I guess either Stephan or Dom, maybe you can add some color to our solution that we came up with and why that was an interesting change to make.
Yeah, that was definitely one of the most interesting changes because it required us to actually do have a change in between the old and the new code paths, which we desperately wanted to avoid. I think we first found out about that when we saw diffs coming in, which were on the type name level, and we investigated what the old code path was like adding and removing. So basically how the code works is we add some type names to selection sets, and then we track, okay, this path, we added a type name to the selection set. So when the response comes back, we can basically go into those paths and remove it again. That sounds like a very simple idea, even though we like one by one migrated that or ported that code to Rust. It even used some stuff that we wouldn't need to do on the Rust side just for the sake of keeping the code as aligned as possible, like also from how the code was written, not just from function-wise. Yet it led to like different paths being added and removed between the two code bases. So that was how we stumbled across it. While investigating it further, I found out that we sometimes keep some type name, like the __ type name fields inside of the response, even though you didn't request it in your query. And I found that to be very worrisome for us. As I said, we want to be like a kind of like transparent pass-through proxy, we shouldn't add data to your response that you didn't ask for, which is like one of the base primitives of GraphQL. Is like you request explicitly what you want to get. And we found that depending on the way your query was structured, you got more and more type names back that you actually didn't ask for. So we rethought the process a bit on how we add that and ended up at a solution where we thought it would be fine. And then we actually figured out at some point that it was now removing too many type names, which is also very awful because now you actually expect the field to come back and the underscore type name is always non-nullable. And yet it might be missing from your GraphQL query response. So that is actually even worse than sending you too much data back. And when we thought more and more about this, we came to the conclusion there is no good way at the point in time where we do this logic, where we can work with just the underscore type name and the mix between user edit and our own edit fields to the selection. So what we did instead was to rewrite it to a point where we add our own aliased version of the type name to it. So whenever we don't find a user edit type name selection, we add our own aliased type name selection to it. That allows us to be very, very confident that whenever we see an underscore stellate internal type name, that we can actually remove it. It's in fact added by us. So if you, for whatever reason, use that as your own aliased version within your query, that might cause a problem. But I don't think anyone would ever come up with that name. Plus underscore is actually system reserved prefix, so you shouldn't use it. So that made us kind of confident that we can use it as our own way of tracking. So we still do the thing where we track to which code path we have edited, which is just more performant and scanning over the whole result. And yeah, now we found like a solution. And that solution is, in my point of view, a good one to do, but it also now has a new set of problems coming with it that we figured out on the way. Maybe Dom, you want to take over for this?
Yeah, so we rolled that out thinking this fixes everything. And then suddenly we immediately ran into GraphQL alias limitation issues on our own API even. So we switched over our internal, or the public API actually, to use the new system, and our own queries from the dashboard started breaking because we had an alias limit of, I don't know, low 15 or something, or even lower. And suddenly we added all these aliases instead of just underscore type name, right? So we immediately had to roll back, look at it again, and found out that there is a default in GraphQL Armor by Escape Tools that is widely used, and probably other GraphQL security solutions out there or custom solutions that impose a limit. So that is, of course, not great because the type name field doesn't really introduce overhead to the server. So it shouldn't be treated the same way. It shouldn't count towards the total alias limit, but that's simply where we're at right now. So there's an opportunity for tooling to be improved. We opened a PR against GraphQL Armor to improve that situation. But yeah, well, we have that limitation now. Same with query size limits. Suddenly the query is a lot bigger in terms of decompressed characters. And that also causes issues with certain limitations that are imposed on the server side, right? This is not solved, really. Like, we basically have to issue a warning right now that, well, this can happen. Please check if you use any of these solutions. But it is an interesting glimpse of GraphQL being seemingly simple in many ways, but then the landscape being very wild and being unpredictable in many ways when it comes to these kind of things.
Yeah, I think this was our maybe 4th or 5th or something like this release attempt, and every single time we got to release there would always be something, and this was certainly one of those. But in the end we were victorious, right? We managed to release it.
Yeah, so we managed to roll it out. People have a toggle now, and if you're listening to this and you have a Stellate service, you can now click a button that makes everything better.
At this point, maybe also an honorable mention to Marco. If you've ever interacted with Stellate, you might have interacted with Marco so far already, our customer success person, who did a great effort in making sure that we get some insights on who is remaining on the old infrastructure, who already moved over, maybe even who had to move back, making sure we get the proper wording in place, asking all the hard questions of okay, is this now correct? Is this all the things we need to mention? What are the implications? What do I need to know? And making sure that we also rethought our knowledge that we had. And I think Dom captured a complete paper, what are the potential differences. There was all jotted out together. Andreas, you also contributed quite a bit to making sure we have a complete documentation page in place, making sure that nobody feels left alone. And then during the release, Marco was basically making sure that this gets communicated to everyone affected and is also now there helping for anyone who's like reaching out. And we had some people who were then like a bit concerned about stuff and reached out to Marco, and he could like calm them down, help them out with some insights. And I think this is the hidden superpower in the background on making sure that everything will go smoothly from here.
It's a very tricky balance. We have a lot of responsibility as infrastructure providers to make sure that people are safe and that production traffic isn't impacted. And so we want to tell them everything that's wrong. But then at the same time, if we, make it sound really scary, then people don't want to migrate, right? So it's like, it's really a challenge to communicate the right level of severity for all these changes, because in the grand scale of things, this is a benefit to everyone. There are minor differences that some people might be impacted with, but yet it is really important to make sure that you test everything before migrating. So a very interesting communication piece around that. I guess the question that remains is, what's next? What is this going to allow us to do? Maybe Thomas, do you want to speak to that, seeing as you're also working in product at times?
I think in a sense, what we just did with one edge provider was just the first step into enabling actually useful things. I mean, we've now talked about a lot of bugs that we fixed, but we didn't start this project to fix bugs. We started this project to come up with a architecture that allows us to build even more powerful and advanced caching features. So I mentioned it way in the beginning. Currently, the secret sauce behind GraphQL caching and with Stellate is rewriting post requests to get requests. This has its own set of limitations. And what we eventually actually want to do is create something like use a cache API, which Fastly is building to allow us to have even more control over what we're caching and how long we're caching it, which might give us, or which hopefully gives us the tools into our hands to build even more powerful caching features, partial query caching. Basically, instead of either caching the whole response or nothing, we cache parts of the response and kind of split the query intelligently at the edge and only send the part to the origin that we don't have cached yet. Building something like this into our three-layer architecture would basically be maybe not impossible strictly, but very, very high effort and probably very, very complex. And what we did now with one edge provider was basically our first and our very big step towards exciting new things that we can build on top of that in the future.
It is very exciting indeed. Yeah, so like one edge provider, we're basically down to 2 levels now. We went from 3 to 2.5, let's call it. And in the next couple of weeks, we're getting down to 2, being entirely reliant on Fastly rather than Cloudflare and Fastly. And then, as you mentioned, getting theoretically down to 1 layer very, very soon. And every single time we remove a layer, things get faster, more reliable, and hopefully also easier for us to build new stuff. So it's a really exciting direction. This is all we have time for today, sadly. This was a massively complex project spanning multiple years, and we could have continued for hours to get a complete picture of all the work that went into the migration. But this conversation was a great overview of what it took to get one edge provider out to customers. Thank you all for joining me for this conversation today. I really enjoyed it. Personally, I'm super excited for all the improvements to come and can't wait to talk to you all about it in a future episode of Build in Public. Thank you very much for listening. Have a good one.